Hello viewers, still on indicial equation. We are going to solve this problem. We have 5 raised to the power 2x minus 4 minus 1 equal to 0, and so we're asked to find the value of x. So start a solution. We have 5 raised to the power 2x minus 4 minus 1 equal to 0. So we have to move this one to the right hand side of the equation, or we can say add 1 to both sides of the equation. So let's say add 1 to both sides of the equation. Note, why we are saying add 1 to both sides of the equation, we are trying to eliminate 1 from this and the left hand side of the equation. So we are trying to take it. So you can either say add 1 to both sides of the equation since it is negative here, or you can say move 1 to the right hand side of the equation. So when we do that, we are going to have 5 raised to the power 2x minus 4 minus 1 plus 1 equal to, since we are adding 1, so 0 plus 1. So we know that minus 1 plus 1 is 0, so this is out. So we have 5 raised to the power 2x minus 4 equal to 0 plus 1 is 1. And so we know that in indices, any number raised to the power of 0 is 1. So if we say a raised to the power 0, it is equal to 1. If we say 2 raised to the power 0 is equal to 1. If we say 5 raised to the power 0 equal to 1. So any number from indices raised to the power of 0 is 1. So we are going to apply that law here to solve this problem. So we are going to have 5 raised to the power 2x minus 4 equal to. Now, since we are dealing with 5 is the best here, 5 is the best here. So we are going to, in the right hand side of the equation, instead of writing 1, we will write 5 raised to the power of 0, because we know that 5 raised to the power 0 is the same thing as 1. And since we are dealing with 5 as the base here, so that's why we are using 5. So assuming it was 2 here, would have used 2 raised to the power 0 here. So when we cancel out this, we are going to have 2x minus 4 equal to 0. And so we can add 4 to both sides of the equation, or we move 4 to the right hand side of the equation. So this will give us, okay, let's say add 4 to both sides of the equation. So the essence of doing this is to ensure that we eliminate 4 in the left hand side of the equation while we take it to the right hand side of the equation. But if it was a positive here, we would have said subtract 4 from both sides of the equation. So there are 2 ways you can do it. It is either you collect like terms by moving 4 to the right hand side of the equation, or you make this mathematical statement, implement it, and then you continue with your solution. So in implementing this mathematical statement, you are going to have 2x minus 4 plus 4. We've implemented it by saying plus 4 equal to 0 plus 4. So because we said add 4 to both sides of the equation. So we know that minus 4 plus 4 is 0. So we have 2x equal to 0 plus 4 is 4. And so since we're asked to find x, so we divide both sides by 2, the number that is multiplying x, so that x can stand alone. So we said divide both sides of the equation by 2. So this will be 2x divided by 2 equal to 4 divided by 2. 2 here 1, 2 here 1, 2 here 1, 2 here 2. And so our x equal to 2. So viewers, basically that is how to solve an indicial equation of this form. Note that in indices, any number raised to the power of 0 is 1. And so we can actually implement it here to interpret the law this way. And we are using 5 here because the base here is 5. So assuming the base here was 2, we would have used 2 here so that we have equal base. Thank you.